And what you see on the screen is, in fact, the product that is our product that's been around for several years. This is actually a browser, and this is built. In this case, I'm running on. Let me do the different screen. If I do help system information, I'm running on IE7. This also runs with IE8 and IE9. This is a clone. Our product, the eValid product, is a clone to the IE browser. You might say, oh, that's unfortunate because I need to run on Firefox and Chrome and Opera and so forth. Well, I'll come back to that. We have a way around that particular glitch. The eValid engine is a C++ application of some 750,000 lines of code with a very substantial capital investment in building this thing. But it is fundamentally a desktop application implemented in C++ that operates on top of and using all the resources of what's called the Trident rendering engine. And if you're in the programming business, you'll know that that's also called MSHTML. And we make specific use, and I'll just throw the words out, not trying to impress anybody, but we make specific use of HTML document 3, 4, 5, and 6 interfaces into the MSHTML document. eValid is intended as a browser, so, and I'm not going to, let's see, let's just look to eValid, just so you see that it really is a browser. I'll go ahead and click and search for eValid, and it should find us. So it is a good browser. It is equivalent to IE, and in fact, when you load eValid up on your current computer, if you're running IE8, then eValid emulates IE8. And if you're running IE9, you get IE9. One of the key characteristics of eValid is that the product is very small, very self-contained, and the product is optimized for testing web applications. One of the features of eValid is that we wanted to focus on the real problem, which is testing a web application. And so input-output is very simple. For example, let me get rid of some things on the screen here and give you some sense. Here is a log file. The log files are simple text files. They can actually be rendered into HTML if you want, which is a pretty trivial task, but we made the input-output all text-oriented because there's a simple command line interface, and the command line interface operates to allow people, customers, users to integrate eValid into a wide variety of applications. Here, for example, is the script language, and this is a script I ran a few minutes ago. And I'll show an example of that in a minute. The idea of eValid is to not use JavaScript as the playback mechanism. Now, you may be familiar with other products like Selenium and Wattier and WebDriver. WebDriver uses Java, but it's really Java swung around and implemented in JavaScript in the browser. eValid specifically does not use the JavaScript engine to playback for two reasons. One, that produces very low overhead, and number two, you do not, because of the way eValid is architected, interfere with the operation of an AJAX application, which of course is AJAX is JavaScript inside the browser communicating with the server. So the idea is that by not interfering with the browser operation, we get very realistic behavior of an AJAX application. Asynchronous, we'll show you a little bit later on how to deal with asynchronicity. Okay, so let me go to the next section and just do a little bit about recording. It turns out, and let me just show you something of the browser face. Now you look at this and you say, oh well, these buttons are pretty old and staid, and in fact the idea here is to distinguish eValid as specifically a test engine rather than a browsing engine. We don't want to hide things like forward and back and so forth, but we do want to emphasize the browser nature, but all of the commands are executed from the pull-down menu. So for example, there's quite a robust set of commands in the GUI here. The claim in the in the example is 99.99% GUI operation, and in fact we've got a very simple paradigm that we recommend to people to record an AJAX app, which I will get to later on, and that's always done from the GUI. It's efficient to do that. Creating a script by hand is inefficient, so we record from life, and then when it's necessary we can manipulate a script. So we make a recording, and I'm going to try to do this. Let's see, how did I do this before? I did it with Google, didn't I? Got to be very careful, because if I do the wrong thing, I get I get into an interaction with the AJAX in Google. So here's my demo of Google. When you'll see that eValid goes ahead, and the first thing it does in creating the script is it deletes the cache and deletes all the cookies. So I'm going to go ahead and type in something here which is designed to get me past the autocomplete look ahead, so when I do the search, I actually do a search. Now I've completed this script just in front of your eyes. That's the script I got. Mouse down, mouse up, mouse down. You don't need to know what all these parameters are, but if you were curious, I'll tell you that they are element IDs in the document object model of the page. So let me play this script back, and I'm just going to let it play back so you can see that it really does do a record play. And it waits the specified number of seconds. I put a ceiling in this particular playback of 5 seconds, so we don't wait ever longer than 5 seconds. So sure enough, there's the command, and sure enough, there's where we go to. Now, the real deal with recording is that at the time that the eValid engine is making the recording, it's actually reading information from the DOM. Now, you can go in, and I'll just do this real quickly here. You can turn on a thing called the page map, which other people call the page viewer or the spy or whatever. Our page map is a little bit simpler to use, and it also is quite thorough because it really does look up everything on the page. There's so much information in a web page that's superfluous to the purposes of testing, and this is just a good example. If you look at all of this material just on one input field, look at all these different assigned values and attributes or properties they're called, all of these things assigned to a particular attribute, gosh, it can become overwhelming. The real deal, the real complicated part of the recording and playback engine is to get the recording right. So there's an enormous amount of information, and eValid goes to a great deal of trouble to record, and I'll tell you what the underlying principle of the recording is, and it's very simple. It's easy, simple to state, but very difficult to build, and that is that you write into the script file the least amount of information sufficient, I'm going to use that term, mathematically necessary and sufficient, remember those phrases, sufficient to enable contextual playback. So state preservation, the preservation of state of the browser, is critical. Now, state preservation for a navigational website where you do just a lookup like this or something else, that's not as important as is state preservation in an AJAX application, because in an AJAX application there may be all sorts of internal information which is used to determine future state of the browser. This particular feature is why, you may be, if you're familiar with the way AJAX works, this is one of the reasons why a record play engine that's based on the DOM is highly successful at handling AJAX playbacks, whereas those engines built on recording HTTP protocol almost always fail. In a way, eValid was ahead of its time, because some years ago I remember talking to people and they were saying, well, I can do all this with an HTTP protocol. Even today, Microsoft tells you that all you need is an HTTP protocol recording, and that will capture AJAX. And those who are working in the field know quite well that that isn't accurate. Well, it's accurate if you don't change anything, but if you're using the features of AJAX, which are to be adaptive and interpretive and dynamic, then the simple HTTP protocol recordings simply do not work. Now, one of the key features of eValid that we built in very early is called adaptive playback. And adaptive playback does things like look around. Oh, let's see here. I'm gonna try this. I hope this works. I'm gonna try. I can't change the way Google works, but I can change the way the script works. I've now, with this script, I've just edited the script and I've saved it back. I edited the script and saved it just like that. The script, when you're recording, is fully editable, and when you play back, it becomes non-editable. You don't want to be editing the script while you're playing back. So I've modified the script because I can't modify the application. What I want to demonstrate is that the correspondence between the script and the application is going to be preserved because of adaptive playback. Adaptive playback, when it discovers a difference between what you're trying to do and what you recorded in the script to do and what you think you want to do, eValid will, oh, look at that, it did the right thing, even though I changed the index. Let's look at the event log and see if we can figure out the reason why that happened. And we don't scroll down here to the part of the page that's critical. Mouse pickup, okay, right. The button here, here's the guts of the. All right, eValid found that button G, btng, was not at the expected index. Now, eValid being the browser, eValid digs around in the DOM and says, aha, the button that I'm looking for with the right attribute, btng, was found at location 183, so I'll go ahead and click on that, but let me point out that that click is this command to have a warning status rather than an OK status. So the ground rule with eValid and adaptive playback is use adaptive playback. It actually can be turned off if you wish, but you use adaptive playback is always to to give the user an indication of whether that was actually done. Now, there's some other features of playback that are useful. I can single step through, and let me just bring the script in. I can stop, and then I can pause. I can play, and then I can pause. And I can go back to single step. It's interesting if I single step. The command. One more thing about this: when I single step through here, and you see the word "done" down here, an important technical characteristic of eValid also is rely only on the appearance of the word "done." Done actually appears in the document object model when the onDocument complete signal is received by the browser, but onDocument complete, meaning done, doesn't mean done. There are hundreds of examples where our more sophisticated playback synchronization, which involves as many as 7 separate signals inside the browser, is required to keep page synchronization and playback running. Okay, so I've made a recording. Now, if I take and I'm going to use a different example here, if I could. We made a recording earlier. By the way, I've exhausted my limit. Stop this playback so I can get control of this. I'm only going to run. From experience, I'm going to run exactly 1 instance of a recording because the ground rule is that no matter what the speaker does, the recording will always fail the second time. So this is a recording made earlier. All right, I'm going to play this back on this AJAX example. I'm going to use this. This is now an example that I'll bring that up in focus so you can see it. This is an AJAX example where we're digging around in the page, and this recording was made from life, and you see we're digging into this complicated selection, looking at the 3rd element. So we pick the 3rd element, and then we go and navigate to that, and then we're done. We can get a nice screen here. If I wished, I could convert these scripts into structural form. Okay, so there's the recording, and let me show you the example I'm going to use, which is the number 3. In number 3, I take the first command, and the first thing I'm going to say is, okay, what I really want to do is I want to make sure that this page is completely up before I continue. So the method that's being used is to act, wait, and then sync. That's the key, act, wait, sync. So I didn't record this way, but the script when I'm done will have this. Here's the action, go to this initial link, wait until something happened, and then before taking the next action, make sure that a phrase is present on the page. So I don't know where HTML controls example, I guess there's where it is. Okay, sync on text will wait at playback time until that particular phrase appears in the visible HTML. Sync on text is visible HTML. There are also syncs on anything that you wish inside the DOM. And I apologize if there's some clicking noise in the background. As far as I can tell, that's not my mouse. It has to do with something about the headset, and I can't find the position, so I'll just I'll apologize if it's annoying, and I'll try to go on. So here's the story. We added that sync. Suppose I want to take the command follow link and convert it into completely positional dependent, absolutely going to work every time commands. Okay. The first thing I do is I look on the page map. So I turn the page map on, and I might look for what the follow link is. I won't do this in real time, but I'll show you what the resources are that we use. So here is the actual page map. HTML select parent. We might go up and down an element. And as you can see, there's a feedback loop here that lets me show on the screen. If you see that blinking, let's see if you see it blinking. Yeah, you do see it blinking, sort of. So the feedback loop is bidirectional between the page and the DOM. Now, there is no magic here. It's just, as I pointed out, there's an enormous amount of complexity. So what I'm going to do is I'm going to use the methodology that we have here, which is called a manual testing methodology. And let me show a picture. I want to bring up a picture that shows what's going on. In eValid, at any one instant, there's a defined value of a variable called source index. There's also a defined value of an element value. Now, the command that I'm using says index set to 0, which says set the index number to 0. And then the next command is index find element from index 0, moving down the page, looking for the inner text of HTML controls example. And this last parameter here is a blank. That's the frame name. There isn't any. And once I've found that, index follow link says go follow that link. Now, if I play this script back, let me get this script over here. Let me go to the picture. What's going on is we're starting at the top of the page. We can also start at the bottom of the page and move up. Sometimes you want to look at the last thing on a page rather than the first occurring thing. But we find the particular element, and then we take an action on that element. So let's see what happens if I run this playback with this script. And so we wait on that. We wait the 3 seconds, and we can stop there. I can stop there because all I really want to do is view the selection. The commands I'm concerned with are right here, setting the mouse index to 0. That took 31 milliseconds. We searched downward at the expense of another 125 milliseconds, and we find what we wanted at index 43. Now, eValid remembers the number 43 internally, so that the next command, which says click on the element, is clicked on whatever this number is. But in playback mode, I never see what that actually is. I don't need to see what that is. So what I've done is I've found a key page fact. I've identified a structural feature. That's that it's called, where is it? It's called, get my thing here. It's called inner text as HTML controls example. I figure out the structural command to use. I insert the manual sequence, and then I can confirm operation. Now, one of the things that's beautiful about this is that there's quite a sophisticated collection of commands. Now, I'm absolutely not going to do the obvious thing that you might think, which is to overload you with resources, but I will show you that there's quite a list of commands, And again, this is one of the pages which we'll forward to you. This is just a page from the eValid documentation. Oh, I forgot to mention the eValid documentation, of course, is here online, so it's easy for everybody to get to. And enough said about documentation. If you don't have documentation, everybody criticizes you. If you do have documentation, everybody sends you an email saying, well, what's the page in the documentation that says this? People don't ever use the search verb. The point that I'm making is that eValid can succeed in locating page features using the page map, and then use index find element, which can find up to 1 or 2 elements. And there's also a command, and you'll like this, there's also a command called index find element expression, which accepts regular expressions. And those of you who are familiar with the language that's nowadays used will say, sounds like XPath to me. And the answer is yes, it is XPath. It's our version of XPath, but it specifically looks for a regular expression, and the index find element expression command allows for multiple matches. XPath allows for a single match per instantiation of an XPath reference. The index find element command allows for identification of a page element that has this, and also a page element that contains this, and also a page element that contains that. Now, index find element expression is a bit of a performance hog, so we only use it when you really don't know what's going on, but it is available to do multiple element searches. Okay. Now, script examples. Before doing that, I want to point out something that I had kind of skipped over earlier, and that is how does this apply to examples that are done other than on a desktop application. And so I've got an example here of here's a trick that we use. This is there's a command in eValid called user agent string, set user agent actually. So what this command does is tells eValid to report to the server that it's something other than the IE browser. So here what we've done is we've taken one phone, which is an iPhone, I guess. Well, this is an iPhone client, right? So we pretend we're an iPhone client, and we render the page as if we were IE. We render 5 different websites: Amazon, Meeboo, Samsung, Sony, Verizon, and so forth. We implement these pages, and we view them as if they were viewed from the iPhone. And what you see is some pretty interesting phenomena here. eValid has some capabilities, and I'll take a little sidestep here and point out that if you look into the log file, you find things in the log file like all the gory details about every component of a page that's downloaded. So I know that there's a thing called that, and a main, and these, this PNG, and all these different little byte counts are all recorded very, very carefully by eValid. So if you move back to this picture, you see that, gee, the iPhone, when it goes to the Sony website only delivers 12% less than full volume. In other words, 6,000 kilobytes, 6 megabytes, okay? Actually, 5.5 megabytes to an iPhone and 6.3 megabytes to a laptop, to a regular screen. So you see quite a variation, 5% to 93%. Look at that one. The Verizon iPhone to a Verizon, the Verizon website says, I don't care if it's an iPhone. Bandwidth. Does Verizon sell bandwidth? Interesting question. Does Verizon have a vested interest in consuming bytes in download? Well, maybe it does. That's one example. The other example is the other direction. One site, multiple phones. And here what we did was we did the same website on 5 different telephones: Samsung, an Apple iPhone, an iPad, I guess, Windows iPhone OS 6, and an Android 2.2 and a 2.3, and the same web page rendered by 5 different telephones. Now, the reason I mention this is that in scripting, particularly these days, the main body of interest in the world is mobile applications or social apps. I mean, web servers are delivering pages now to desktops. They're delivering pages to tablets. They're delivering pages to HP tablets, if there are any of those left. I understand there's some very good prices on an HP tab, but that's a little joke. They're delivering, most importantly, delivering data to iPhones, mobile devices, smartphones. Now, you know, I'm of the generation where the smartphone is sort of overkill, but there are people who cannot be separated from their smartphone, and that's the way things are. You have to accept that. The point I'm making here is that eValid, if you build a well-organized, well-structured test using these principles that I've been describing, then you can run that test against every one of the different types of devices, and you don't have to have a lab full of equipment with all the different devices. The question came through on the eValid user forum the other day about this, and someone said, well, gee, where do you guys get off saying you've tested a web application from an iPhone if you don't do it from an iPhone? And the answer is, we're not testing iPhones. We're not testing iPhones. We're testing web applications that are delivered to an iPhone. Okay. Now, I won't go through all of these details. I just want to point out that there is quite a, let me find my example, there's quite a body of examples, and I'll send this link to everybody who's attending because I know it's way too much information. But for example, let me take this example. I want to look for the nth. Here's the structural test passage for looking for the nth item in a drop-down list. There's a drop-down list. So I want to look at the nth item, and this is what the sequence looks like. This is what was recorded from life, and here's the three command structural sequence, which always works regardless of how the page is actually rendered. Okay, this is on Quirks mode, something or other. I don't know where that is. Click, let's see, compare two values. Let me do another example. Dynamic tag, just a simple navigation to an application. I guess we've kind of done that one. Index follow link, find the tag name. Something a little bit more interesting, find a dynamic tag and click on it. This is a tag, and the format's going to be to find something in the page. Find something in the page, and here's a good example. Find something in the page, move down one further step, then do a mouse down and a follow link. It's interesting that the element mouse down command, now this gets pretty complicated because you're looking for an inner text, you're looking for composed mail on frame number 3. Let me tell you a little bit of the story about frame names. The good websites use frame names that are unique and never change them. The bad website suppliers, the bad web applications like GWT, use frame names that change from instance to instance. So we have a solution which gets around that. We simply record in terms of numeric frame number. That's the order of arrival. So here's a case where you're checking for two things. You put the mouse down, and then you do a following. Now, a comment here about index find element expression. If you run an index find element expression on a large web page, be prepared for a performance hit because it can be rather slow. Okay, this is actually the wrong page, so I'm going to have to click. See if I can maybe I can correct the outline here by doing something a little bit different. I want to get to the correct outline because something goofed up with the. So I'm going to eat up a few of my precious minutes to see if I can get to the right outline and see if that gives me something better. There we are. That's the right outline. Good for me. A couple of examples that are, how do you use this? Number one, for one thing you can do is you can use this for monitoring, and an application monitoring is no more than a functional test, and I'm just going to show this example. This is on our website, demo. Hope it runs. Log in. Edward can't type demo. T-E-M-O, return. There we are. So if I look at this one and just look at some raw data here, I can get a report. This is done with the groundwork open source monitoring, but the script that's being monitored from a computer here internally shows a couple of gaps. We had a power failure earlier in the week, power outage, which shows up here. These bands are timing bands that are done inside this structural test. I won't spend more time on that. I just want to illustrate the monitoring as an example. The other example is server loading. So Whaley, let me hand that to you. You've got an example ready, I think, that's going to illustrate using server loading, okay?
Okay, hello everybody. One moment, let me try to swap screens here.
You get the screen, okay? Okay.
Okay, can you see my screen?
Oh, there's a screen. I see your screen. Really good.
Okay, basically I have a simple test2.evs which is going to save a record of the first command's instance timing, and this is by going to the www.google.com and then going to our website where we've created a live synchronization page which has a stop-go animation. And then once we've synchronized on the word running, we're going to download from our website a HTML file which is about 100 kilobytes. And of course we'll save the details on the elapsed time. So here's the basic EVS. Once you have that, you need to create a load test script. So I'm going to create a load test script which is going to perform 100 browser instances going to the Google web page and running through. Go ahead.
I was just saying that particular screen you're looking at, the scenario editor, is part of the eValid load test capability. Load testing is done by running multiple browsers in parallel. Keep going, Willie. Go ahead and run that one.
So yeah, so it goes in. Here's the script. I'm going to go ahead and say go. It's going to take several minutes for all the browsers to start loading up. So you see this script is launching, traversing through each of the commands to launch an eValid browser. And you know we have the minimize switch parameter added, so it's going to come up on the desktop.
The server loading engine is using the batch interface to launch a collection. In this case, it's going to be 100 simultaneous browsers, but we're going to launch them minimized. eValid, because it operates at the DOM level, doesn't need to have access to the screen. So keep going.
It's
still running, huh?
Drilling down the script file. We're at 66 browsers now.
Now, while that's running, let me add that there's no distinction made in the playback script. This example, of course, just drives a local file, but that playback script could be driving a mobile application. It could be driving a tab or a handheld, a smart tablet application, or a desktop application. And when we do these kinds of projects for customers, we use cloud resources. I was reading an article this morning about how it's important to do mobile testing from the cloud. Well, we've been doing mobile testing from the cloud for some time. Are we ready yet? Is this thing launched yet?
It says 91, so 97, and now we're at 100. So if you're able to see the bottom of my taskbar, there's 100 browsers all minimized there. I'm going to show them side by side now.
Okay, so you'll tile them out. Now you see 100. I do see 100. I'm watching, so there's a time delay between when you see it and when I see it.
Yes, about 10 seconds or so, I believe. I have all 100 up. Do you see all 100?
Not quite yet, but I see. Ooh, I see 100. I see 100 boxes, all of which go ahead and say go.
Okay, so I've expanded one of them so you can kind of peek into what each one of the minimized browsers are doing. And we go back to my stop go synchronization page, and I'm going to go ahead and click go now, which changes the signal to the word running.
Go ahead, click it.
And each of these individual browsers will synchronize on that and perform the go-to link to fetch the 100 kilobyte web page.
Go ahead and click. Oh, you've already clicked.
It's been
okay.
clicked. It's
Sorry,
just that you're.
Yeah, I'm watching in past tense. Okay. So what will happen is each of these scripts runs, all of the browsers will blink off. There they go. So they all turn themselves off. Okay. Why don't we? Do you have a at the end of this? Do you have a test report summary? A load test summary. Yeah.
Yes.
So there's a special monitor that is included here, and this should show all 100 of these having finished with min, max, and average time. So, okay.
Yes.
Now, as people, and that's very good, Whaley, appreciate that. Why don't you give it back to me then? Got that part done. Good. As people may appreciate, it's really hard in a few seconds to illustrate how server loading works. These projects take a day, half a day, or a day to set up and run. We achieve a scalability of about 100 browsers per user account, and on a cloud-based machine with 10 users, we get 1,000 browser users. Now, it's easy to get 1,000 browser users if you don't care about reality. If you want just the equivalent with HTTP, there are free products that will get you the equivalent of 1,000 users. But this is 1,000 actual browsers, each one of which operates independently of the other, has complete context, and operates with complete realism, and can drive a mobile app or a desktop app or a tablet or whatever. Now, a couple of comments just to kind of summarize here, because we're coming up on the 45-minute line. Remember the thing I've emphasized, that we believe it's far more efficient to record from life and then edit a script than it is to try to script from scratch. Another topic worth mentioning is what I call page forensics. Unfortunately, the world does not cooperate completely, because in some cases you do need to do a little bit of discovery work with the page map in order to find out exactly what's going on. That skill is simple enough to learn. Most people pick it up pretty quickly, but sometimes we have to set up a little training session or a go-to meeting to handle that. Pages that are dynamic and change dynamically are the most troublesome. If the page is truly AJAX, then what's on the page is a function of how the page and the server are interacting. And that means that the page map itself may change. So there are serious problems and some subtleties when the page is dynamic. What we call AJAX desynchronization occurs. So the solution to AJAX desynchronization from our perspective is to, when in doubt, synchronize once. If one synchronization is good, multiple synchronizations are better, and the mechanisms for synchronization are very well developed in eValid, because as you will see here, you can synchronize with this command, and I don't want to bore you, but here's a command that shows all the varieties of sync on a selected object property. In many cases, we have to do our little page forensics trick to find the particular element property which indicates that the page is fully synchronized, and so we can do that kind of synchronization. So that's pretty much the advisories there. So what I've told you is about the eValid product and technology, about test recording, about test script development. We've illustrated script development with a couple of examples. We've shown you some resources that are available. We've mentioned how to handle mobile applications and non-desktop applications is a very better way of saying that. And we talked about monitoring, that is the application of a script over time, in singleton mode to collect data about performance, or server loading, which is the application of multiple scripts all at the same time to collect capacity measurement information. So that's pretty much where we're at.